Hello, hi Naveen. Good morning. The session is live on YouTube. Just check once. We should be able to see this. Yes, Naveen. I'm sharing you the link also here, and you could, yeah.
Suraj, it's a perfect. It is under streaming, live streaming.
Okay, Naveen. I think you got a link, I believe, right?
Yes.
Okay. Right. So also, let's share this link here. Right, Naveen, I think from our side, we are all set to go.
Hi, very good morning, Ranvijay sir. Is my voice audible to you?
Yes, sir.
Yes, sir. I hope you have received the YouTube link.
Yes, sir. I have shared a YouTube link with the students. And our volunteers are ready. If they are okay, then we can start the session.
Suraj, shall we wait for the next 2 minutes?
Sure, sir, sure.
Yeah, no issues. I think we just can wait until everybody get joined on the YouTube stream.
Sure, sir, sure.
So I'm just checking on how many people have joined. Yeah. Okay, Naveen, I think that we can ask Sushmita. I've shared you the link as well. All right. So we can just ask Sushmita, Vinayak to send the link to all the students as well.
Sure, Suraj.
Naveen, I think we have about 13, 15 students right now on the live stream on YouTube. So, Ranvijay sir, maybe if you have, any of the groups that you have, whom you prefer to join for this session, so we can also add them up for this.
Yes, sir. I have already shared link. I think within 2 seconds they will join from our WhatsApp.
Great. Okay. So I think we should be good to start. Maybe over next few minutes, more students may going to join the session as well.
Yes, sir. Aritika, let us get started.
Okay, sir. So should I start?
Yes, please go ahead.
Okay, thank you, sir. For a sustainable future, every nation needs the latest technology. Good morning, everyone. I, Ritika Sharma, final year student from Department of Electronics and Communication Engineering, welcomes you all to national level one-day workshop on electrical vehicle technology. This workshop is being organized jointly by Electrical, Electronic and Mechanical Engineering Department in association with Decibels Lab, Bengaluru. I welcome Honorable Vice President of Sri Aurobindo Group of Institutes, Mr. Kinshuk Trivedi sir, Director Dr. Durgesh Mishra sir, Vice Principal Dr. Anupam Mandloi sir, respected HODs, faculty members, and dear participants. In today's workshop, we have 3 sessions by the experts from Decibels Lab Bangalore. For the first session, we have Mr. Suraj SD, the CEO and co-founder of Decibels Lab. Mr. Suraj is a graduate in engineering with more than 8 years of experience in automotive industry. He has worked on projects with Mercedes-Benz, Fisher Dynamics USA, Fiat Chrysler USA through ITC Infotech on automotive subsystem design. I welcome you, sir, and request you to please start the workshop.
Thank you very much for your good introduction. So, by the way, it's a great opportunity to share the knowledge that we have, and very much excited and also see a good support from the academics to make such kind of sessions happen. And specifically, thanks to Ranvijay sir for coordinating all the activities from everything to plan this session and host this session, and also the team from Naveen side at Decibels Lab to make this event happen. And definitely, EV is the present technology, and we anticipate that to grow much more in next 30 years because a lot of new products are getting launched in the market. New technologies are coming out, and with that way, we still see the maturity of technology is going to still evolve because we didn't have fantastic IC engines on the day one. The gradually things got improvised over the days in place. The same way we have limitations on battery technology for the range achievements. We have limitations in terms of charging technology because the time that is taken for charging. We have limitations in terms of grid availability or energy availability itself at the grid. Or we also would like to optimize the available energy, not only from thermal power plants or non-renewable sources. We would like to enhance more on the renewable sources because effectiveness of EV to reduce the emission will become more larger. On the other side, there's a lot of scope for thermal issues of the batteries. There's a lot of scope for fire accidents in the batteries. And like this way, there's a lot of scope and everywhere that we can do. And this is the same way the IC engines have gradually come up to a very good maturity stage, but we still see that, okay, there's a BS6, maybe BS7 may come, BS8 may come, because we're still trying to work out that how do we reduce emissions in IC engines, even we have evolved over 100 years. The same way EVs are like this, and they're budding maybe like last 10, 12 years has been the predominant technology growth in the automotive electrification sector. So we would see that large things are happening. So with that as a scope, when we say things are happening and technology is being developed, the idea here is we need engineers because those are the ones who put the layout foundation and develop things in place, take care of testing, take care of validation, take care of homologation, take care of collecting field issues, evolving the product over the lifetime to make sure that the things are always better at the shape. So if we see today that there is a huge requirement in the market for engineers to work in the EV sector, but on the other side there's the shortage of subject matter or a domain-specific engineers, because we have very few maybe universities or colleges in the country who offer such kind of courses or being trained on those specific areas. That's how Decibels has come up into a picture that how we can contribute to a growth of creating engineers in the country and in associating with already established players in the market today. So this is an example today that we are conducting the training program in association with a fantastic institution like Aurobindo Institute of Technology, and we would look forward supporting in the same way. And we have been selected by Government of Karnataka to set up a nodal EV training center with a grant from Government of Karnataka in here. Same way we would like to associate further for the future activities in place. So I thank for the management in making this effort of organizing this session, and thanks a lot everybody for coordinating together to bring the session into picture. So any of the dignitaries would like to have some words, or if not, I would like to continue my session further. So anyone in the meeting would like to share upon your reviews or inputs to the today's session. So over to you, please. If not, then I'll continue the session. All right. So great. So well, let's get started with the session. So the first session is handled by me, as I'll be briefed about one of the person here. So I will be taking up the session on EV subsystems and career opportunities. This is supposed to be a two sessions clubbed together as a one. I would like to run as much as possible, as quick as possible. So everybody will let's get started with the first slide. So everybody tells that EV is eco-friendly, but yeah, it's very easy to say EV is eco-friendly. But how do you prove that EV is eco-friendly, right? So how do you say, because we are engineers, we need to prove things with the values and numbers. So end of the day, when we say EV is eco-friendly, we still draw the energy from the solar thermal power stations, right? So the coal has to be extracted, or natural resources has to be extracted. Then there is a lot of emissions in extraction, and then there's a lot of emissions in transportation of the fuel from the extraction place to the refinery or further to the power plant. Then there is a lot of production of chemical energy into thermal, and there's the losses. And then again, you use that thermal energy for various different kind of transformations, and then you get an electrical energy. So you transport the electrical energy from a specific location to your household requirements. So there's a lot of transportation loss as well that happens there. But in making that production, so you create a lot of emissions, not only at a production of electricity, but also in the extraction of natural resources as well. But there's a lot of losses in the between process where you convert a chemical energy into a thermal energy, and then for the process of converting the thermal energy into a steam, and then the kinetic energy. For all these things, there is a loss. Then there's a transportation, there's a loss. That you do a step down, step up, there's a loss. Then the energy comes in the format of AC to your household applications. You plug the charger and you charge the battery. So you do a conversion of AC to DC back again, and then there is a conversion losses all into a picture. So then you send electricity to charge the battery in a format of a DC. You convert the electrical energy into a chemical energy as a storage format in the cells. So there is a conversion loss again. And then when you want to discharge it, you convert a chemical energy into an electrical energy, send it to a motor controller. Largely, you supply a DC. So then you convert the DC to AC, because most of the applications, the motors used in the EVs are AC. So there's a conversion loss. Then you convert electrical energy to a mechanical energy, then to a transmission, you send it to our wheels. So when you see through the whole process of it, and when you see everything happening in the whole vehicle for the charging purposes as an EV, so how do you justify EV is eco-friendly? It's very, very kind of a stigmatic to tell that okay, EV is eco-friendly. So this is just what we're discussing about how do we sources of energy and then charging the batteries in place. So this is what we should always see, how EV is eco-friendly, because if you're venturing to EV, if you don't know why EV is and how EV is eco-friendly, it is not really worth. So with this picture, so what we see is we need to see some of the bigger picture, from where do you extract the raw material, and then how do you transport it, and then how do you put it to the wheels at the last. So when we see EV is largely eco-friendly, definitely from here to here, fueling to our wheels. It means you charge and then you run a vehicle. So there's no emissions, but if you see in the backside, there's a lot of emissions also that happens. But now we need to quantify those emissions and come to a picture that, okay, to prove EV is eco-friendly and how much it is eco-friendly really. So here is an analogy that is in detail that an average mid-sized car like a Swift is driven over 10,000 miles. That's close about 18,000 kilometers. How much is the emission it is going to make if it is gasoline, if it is EV, if it is EV charged with renewables, right? So this is an analogy, but we need to prove this. How is it going to be true? And let's just go ahead and just try to jump into the pictures quickly. So let's take a very simple example of a petrol Activa and then the Ather bike, right? So we have like 50 kilometers per liter, what an Activa gives, an average number with respect to ARI. And I'm just trying to put down some details here. These questions are already solved, so there is nothing much to solve here. It's just an explanation I'm just trying to put across. So calorific value of petrol is like 9528 watt-hour per liter. And average energy consumed is basically the range, like the energy of the calorific value of the petrol by the range. And then you get about 190 watt-hour per kilometer. Then obviously this is at the tank to wheel, right? So you just, but again, there's a lot of losses that happens in the process of transportation, refinement, and all these things. So we call about 67%. It's a details available from some of the specific researchers from ministry. So 67% is the average efficiency of the conversion. So we put together all the details to come about 284 watt-hour per kilometer is what the Activa consumes to run it for 1 kilometer. You compare that randomly with Ather, that is a known bike in the Indian market. So we just put out some value. This should be 75. Apologies for the corrections. The battery pack is about 2,400 watt-hour. So if you put across all the values together with the charging and discharging losses, and then production and transmission efficiency and all these things in place, so it comes about 133.33 watt-hour per kilometer. That means the energy consumed by Ather per kilometer is much lesser than compared to our Activa. Now this is at an energy as a value, right? Now we want to come to our emission. How much emission is the vehicle is going to make? So we know the CO2 content of a coal is about 660 grams of carbon per 1 kilowatt hour. And CO2 content of a fuel is about 530 grams per carbon. What we're assuming is you're trying to get the energy from the coal power station, right? When you're trying to get it from the coal power station, you're burning a coal. It means if you're able to produce 1 kilowatt hour energy, so you would possibly push about 660 grams of carbon into the atmosphere. So put that number into a place, because we knew that the average energy for Activa is about 284, right? And then if you comparatively put the values together, then you get about 150.73 grams of carbon per kilometer. If the Ather, it makes about 87.9 grams of carbon per kilometer. If you get the specific value in place, you already able to understand that the emissions per kilometer is about 60% lesser for an electric bike compared to a petrol, same competitive vehicle segment, right? So now if you're able to produce the energy from the renewable sources, right? So if you have a solar rooftop and you're able to store the energy, you're still going to make emissions, because the solar cells are made from silicon and a lot of these materials are in place. You made emissions in the atmosphere. After 20 years, the solar panels are going to be not in a good shape and they may be useless as well. So you will make emissions, but comparatively, if you actually charge the vehicle by renewables, then the amount of emissions that you make comparative to petrol or a diesel vehicle is far, far away. That means they can contribute really better to the environment. This is a way we've kind of proved that EV is eco-friendly and it is good for the environment. And statistically, that is also true. And maybe the values of here and there are a little bit different in depending upon country, depending upon systems in place. But overall, we can prove that EV is good for the environment. And if you again recharge EV with the solar panels and stuff like that, and if you renewables overall, so you would make EV to be much more eco-friendly as well. Then specifically coming to the one more question, that what do we do with these batteries? That is a typical problem statement that everybody comes up with. So today, if you burn a petrol, so you get a carbon. So that there's nothing as a recycling that we can do. But when you talk about EV batteries, we can use the vehicle battery in the vehicle for about 6 years. After 6 years, when we call it the end of life, EOD for automotive applications, we can take out the battery. You can use the same battery pack as a UPS for your house, because the batteries are still capable of holding the energy, but they're not suitable for an EV application. You may still continue to use it as an UPS for 5 more years. At still the end of life that cannot be used as an UPS, you can actually take out the cells and then extract the materials. Maybe it is lithium, maybe it is copper, it's aluminum, or it's nickel, cobalt, whatever the materials that are used depending upon the chemistries of the cell, you can still extract that. Right. So there is a process that you can extract, but yeah, how many people will do it? That is a question that we need to be responsible in doing it. But yeah, overall, I would say EV is an eco-friendly thing. Now let's jump into the technicalities of the topics, that what subsystems are there present in the electric vehicles, and then how this technology plays a vital role. And then on top of it, what career opportunities you may have as an engineer to explore career in the EV sector. So let's get started with the very first subsystem, right? So transmission. We may have transmission, we may not have transmission in EVs, depending upon kind of configuration that we have to build. Let's say you want a vehicle, like you see a lot of scooters, the motor is within the hub of the wheel, right? So that means there is no transmission required, typically because the motor is within the wheel itself. In some considerations, there is a motor within the wheel, but there is also some amount of transmission is there. Okay, that is some little complicated mechanism they have built around. And some vehicles definitely will have transmission. Like if you take an Ather, right? They have a transmission, even it is being a scooter. And if you take any other vehicles, obviously the four-wheelers or stuff like that, they will have a small size transmission. We'll discuss about all these topics gradually and slowly as well. Then we have a motor. Obviously, everybody would be aware. So we would have a motor to convert electrical energy into mechanical energy. Again, we'll go in depth what kind of motors are used, what is the requirement for EV application, and how complicated are they, and stuff like that. So then we have a motor controller, which is basically called as a traction inverter, right? So there's a transmission, there is a motor, and then there is a motor controller. So then we have a battery pack. So that is where you store the energy. So the battery pack is a configuration of cells and put together as a modules, and modules put together as a whole big battery pack. We will again talk more about these things. I'm just showing you architectural level of the system. So then we have charger, which is an onboard charger. There are two types of technologies, which is an off-board charger and an onboard charger, right? The onboard charger is the one where the charger is within the vehicle. So there is a space for that charger to be there within the vehicle. So it's called an onboard charger. We again talk more about technical stuff for the chargers as well. Then there is another side called fast charger, right? Quick charger, right? DC charger. Right? Typically, all the DC chargers are fast chargers. Again, we talk about more on the technical stuff of the DC chargers and stuff like that. But then there's a component called DC converter, right? So what is this component called DC converter? This is basically like, if you would like to run the lighting system, or you would like to run the music system, right? Or you would like to turn on the indicators, horns, whatever it is, they all run at 12 volt, correct? And if it is a truck system, like a commercial vehicles, the typical rating is about 24 volts, right? So if it is commercial vehicles, it's largely it is 24 volts. If it is a passenger segment vehicle, it is a 12 volt system. Now the battery pack which is there in the vehicle is largely about sometime 48 volts to up to even 1000 volts. If you go to a bus architecture, it can be as large as 1000 volts. That means it's very largely sized battery. So you cannot just take a wire from there and connect it to the bulb, right? So that's why you need a system that kind of steps down that higher voltage to a lower voltage requirements. That's why we have a DC converter. So then going to further, we also have a battery management system. That is to take care of battery monitoring activities, such as to ensure the safety for the battery. Also, it is to take care of certain activities such as measurement or estimation. Okay, we call it as SOC, SOH, SOP, SOE, a lot of other things. It also takes care of it. So when you define specifically called, like when you take your mobile phone, you see, okay, I have a 60% charge left. There's a lot of complex algorithm that is there in the behind to actually figure out what is that, and what is that 62% is all about. So basically that BMS is a component that takes care of that activity as well. Then we have some other components such as heater and a compressor. So heater is something that, battery is not comfortable apart from the specific bandwidth it can operate. Let's say it's very comfortable within 20 degrees Celsius to 35 degrees Celsius, something like this, right? So if it is going above that specific value, then the battery will not be in a good operating conditions. It means its discharge characteristics and charge characteristics changes with respect to influence of temperature. So if you tell that, let's go to countries like US or any other specific countries, right? Like in Europe and stuff like that, Scandinavian countries, Norway, Finland, or Sweden. So temperature falls down below zero sometimes, even it goes to like -5, -10 as well. Then what happens if you have an electric car and let's say you park your car somewhere, and then over the night, the temperature of the battery falls really, really low, right? So when it falls really low, the internal structure of an electrolyte can even become freezed. It isn't supposed to be in a liquid format. It can go to a slight crystalline format. So at that time, you can't expect the reactions to happen as the same way it happens. Obviously, the rate of chemical reaction that happens at specific temperatures is completely different, because we all have studied chemistry, because there is an influence of temperature for the reactions to happen. Then again, because the temperature is low, the ionic movements also will be very different, right? So with all these considerations, there is a thermal comfort for the battery, all right? So if it should not be going below the specific temperature, and it should not be going above the specific temperature. So for that purposes, it has to be within the specific bandwidth of temperature. To that bandwidth of temperature, you need a system that is called a battery heater and a battery cooling system. So if you go above a value, if you go below a value, you have to have a system where it can bring the system back into the specific desired temperature, so that you could extend the life of the battery. You can also get the best out of the battery, and you could keep the battery in a good health condition. So that's all what it covers together as all the components in the EV as overall. So now we can go to each topic a little in depth, so to understand how do they look, and how do they function, what kind of technology is behind of all these things. Okay. This is like a 5-day session. I'm just trying to cram everything into a quick 1.5 hour session. So if you have any questions, I could see some of the participants in the chat box as well. They're on our YouTube channel. By the way, thanks a lot everybody for joining in. So yeah, anybody have any questions? So please do share your questions here. It would be great to address your questions as well. So anybody have any questions at this moment? So looking at the chat box here on YouTube. Right. So, all right, looks like we don't have questions. By the way, if anybody have any questions, so yeah, please do share your questions here, so I'll be able to answer them as well. So just give me a second here. Okay, so now let's get back into the topic. If you see largely the same components you see on the vehicle as well here. So there's a battery pack, which is in gray color, right? So then there is a distribution box, HV battery power distribution box. It means like it is like an extended socket box, right? So you have to supply the energy to the battery, and to get it charged, you need to discharge the battery by supplying it to different components. So you need something that it can just distribute the energy from the battery to various different components. It is not like just cut a wire and then you just join the wire in between, right? Because these are the very high voltage systems. It can be potentially dangerous as well. So you need a proper system that can take care of energy coming into the battery, energy going out the battery. So for that purposes, we would have a HV distribution box, which is mentioned here. So then there is a HV battery management system we have discussed in the past. Then we have a component which is like a motor here, right? So you may need a DC-DC converter. It is boosting up sort of a thing, but you may not need it always. Only in some applications. Some companies use the battery pack, but they want to boost the voltage from, let's say, 350 to 420, something like that, right? So that time they can use DC-DC boost, and then they can supply that to the motor controller, and then that drives the motor in place. So what you see exactly here is a HV axle drive with an integrated inverter. It means there's a motor and it is having a motor controller within that module itself, right? Which you guys see here as a motor controller module. So you may need this component, you may not need this component. Because if you have a motor running at 350 volts, and then your battery is also at 350 volts, you can just directly club them up together with the integration of the motor controller. But you don't need, if you need it, but if you have a voltage architecture slightly different at your motor, but at your battery is different, then you need a boost systems. So then you see a simple cooling system also for the motor as well, because motor and a motor controller requires cooling. That means you need to have a system to take care of cooling in place. Then coming to the further components in place, that you see a vehicle control in it, then there's a HV battery management system, then there's a coolant flow control valve to take care of battery cooling, electrical pump because you need to flush the coolant into the battery pack, so you have a pump there. Then you have a DC-DC converter. This is not an optional system, this is a mandatory system, right? So this is a component which we have. Sometimes even this power electronic component, which is DC-DC converter, also requires cooling because you're converting 350 volts into 12 volts, right? Multiple stages of step down. In the process of you do that, there's a lot of thermal issues that can come up at power electronics. So you need an efficient cooling system as well. That's why you see there is a coolant coming out and going in and coming out from somewhere here. So yeah, this is an overall very, very top level architecture. There is something called as an onboard charger, which is here, right? So the onboard charger, as I already described you, it is a charger that is inside the vehicle, which kind of helps you in charging the vehicle as well. Now let's just go one by one and try to understand technical stuff. So right, so if anybody in the chat box has any questions on YouTube, so feel free to ask any questions also. Right, so let me just stop my video to save the bandwidth. If you see here, this overall details of this slide, giving you an idea that about motors and also about transmission as well, right? So when we talk about motor and transmission, so here we are trying to talk about what kind of systems do we require as a part of the overall vehicle. So here we have Aether's configuration, right? So there is a motor and there is a simple transmission. Then there's a motor which is within the wheel itself, correct? Here also there's a motor which is within the wheel, and then there's a configuration of Nissan Leaf. Okay, so here we see a motor, and then there is a transmission as well, which is a very simple and a small size transmission. Now let's talk about two different things. One, okay, so what kind of motor is required for an EV application? So as we just generally think over this, that the motor for automotive applications are more complicated to have than a motor for a general applications. If you're talking about motor for a EV application, right? So it has to be be more precise in many conditions, such as the motor is subjected to a lot of vibrations, right? And because you're riding on the vehicles, there's a lot of potholes on the road, unevenness of the road, that is all creating vibrations, right? So now motor for an EV application should be able to withstand the large amount of vibrations compared to the motor that is used in industrial applications, right? Because there you don't have much vibrations. It is typically like a very defined environment. Then if you take an example for an application like an automotive, we have thermal issues as well, because you can buy a vehicle, you can drive it at your place, you can take a same vehicle, you can go to Himalayas and drive it as well, or you can go to city like Chennai or somewhere in Rajasthan, so where the temperature is really, really hot, correct? So when the temperatures are really, really high, then what happens is the motor also becomes warm, right? Then the efficiency of the motor comes down because temperature of the motor influences the efficiency. Also, if the temperature goes high, slowly, the permanent magnets tend to lose their ability of magnetism. So like this, it means the motor for an EV application has to be more good, or more rugged than compared to an application like an industrial applications. So then on top of all these things, the motor for EV is supposed to be IP rated, is basically ingress protection. That means it need to have susceptibility for water to go inside. That is when the regulation of IP67 is coming into a picture, where you do not want the water to go inside the vehicle, inside the motor, even the vehicle is submerged in the water for an X amount of duration, right? So at a X depth, they test the vehicle. So it is called as an IP rating, ingress protection. So the water should not go inside the motor. So like in similar, we have different complications for selecting a motor for an EV application. Example, another is the dynamic load, right? So if you take a motor for any other applications, the load may not be so much dynamic in nature. But here, when you drive the bike on the road, you imagine, how do you accelerate your vehicle? How do you decelerate your vehicle, right? It means you're suddenly giving a throttle, and then it means you're expecting the vehicle to accelerate very quickly. When you're decelerating a vehicle, you may just brake suddenly and then stop the vehicle. So it means the requirement of the motor, or a capability of the motor, should be very strong enough to supply a sudden change of requirements. It may be RPM or it may be torque, right? But still it should be highly efficient as possible. And then taking the last word, highly efficient as possible, the motor should be also be capable of operating at a higher efficiencies as well. It means if you are consuming less energy, then you're getting a higher range in the vehicle. So for this purpose, the motor has to be more efficient compared to other applications, so that you can save energy as best as possible. So I put across all these terms that you understand that motor is not a simple thing, right? So today we talk about motors with 96%, 97% efficiencies for automotive applications. On top of all these things, the motor has to be weighing less. It means, watt hour per kg should be much better, because if the motor is very heavy, right, it means that the vehicle has to be, motor should be kept in the vehicle. It is adding a weight to the vehicle itself, and then it means that it will in turn draw energy to run it, correct? So in this condition, the motor has to be slightly weighing less compared to another applications. It means it has to be more better in terms of watt hour per kg. Also watt hour per liter, when we call it as, it means the volume of the motor has to be smaller as possible, so that we could use that in the EV application, because you don't have a big place to keep the motor, right? So you want it to be as compact as possible in terms of size. You want to be as powerful as possible with a given size, right? So that's another requirement. So when you put all these requirements into a picture, what you get exactly is the designing a motor for EV application is more complicated than for a general application. So that is why we need a lot of engineers from the background of electrical engineering to work to develop new motor technology. All right. So that is how the journey of motor technical things will come into a picture. Their industries are expecting you to be very good in electromagnetics, right? You would study electromagnetics as a part of your academics. Then should be having very good idea of characteristics of the motor. It means how do they behave. You study these things in your academics because you conduct a lot of experiments on motor testing, right? So what kind of tests are conducted? What kind of desired results are you expecting? All right. So then you should have some exposure to materials. On top of it, you need to have an exposure to simulation toolboxes, such as Flux. Like there's a MotorCAD. You might have known or not known, but I would suggest you that you should have some idea on these softwares as well. If you have the fair amount of knowledge on these three things, then it means that you are going to be a expected motor design engineer. All right. So if you're anticipating for this, then you should have some of these knowledge areas. Then coming to the topic of other things, such as transmission. So any questions from anyone on the areas of motor? All right. So if we also see maybe one more interesting topic of the motor as well, that the life for the motor should be also longer as possible. Why? Because the motor in EV application, right, should come for a long time. Because as an Indian customer, we are expecting the motor to be coming for as long as possible, right? That means we want the vehicle to come for 10 years, 20 years, 30 years and stuff like that. It means the life of the motor expected is also large, okay, including all the other factors. So they can become a part of the journey to be a right motor for the EV applications in place. So now let's get into the side of transmission. So again, floor is open for questions. If you guys have any questions as of now, so please put the questions in the chat box. Right. Anybody have any questions in the chat box? Okay. Perfect. No questions as of now. All right. Let's go to the topic of transmission quickly. So when you talk about transmission, right? So we need a transmission to help us in specific requirements. So the major requirement is the vehicle have a specific torque requirements. It means if you supply a torque like this, then the vehicle will move, correct? So now with this scenario, the motor should be capable of providing that amount of a torque. So let's just take a simple, a picture that what do you require as a torque, right? Let me just draw a pen and then show it to you across. So if you draw a torque characteristics, right, of the motor, the torque characteristics would come something like this, right? So there is a multiple set of torque characteristics. One is called peak torque. This is called nominal torque. The nominal torque is a torque that the motor can continuously supply within this bandwidth. The peak torque is something that the motor can provide, but it is limited for a specific duration. Okay. But if you tend to operate the motor continuously in the peak region, then you may impact the motor life, or you may operate the motor at bad efficiencies. But it is possible that you can operate a motor at a peak torque as well than the nominal torque defined to be in a specific duration. Now, this is a way you select the motor for an EV application. So the motor should be continuously operating at a specific point, and then it should be also operating at a peak torque region as well for the given requirements. Now, the transmission, what happens is it becomes a in-between thing that, okay, you have a transmission gear ratio of, let's say, 1:3, right? So in this scenario, so you can just expect that, okay, this is a 50 Newton meter, right? You can either increase it or decrease it by using a transmission in between. Correct? That's the overall objective of a transmission. So what happens when you use a transmission is you can size the motor optimally. If you do not have a transmission, let's take a first condition like this, right? So where there is no transmission in the vehicle, the motor has to be kept within the wheel. That means the wheel will become more heavier, correct? Then if you drive the vehicle on the road, if you hit a pothole or a bump, the inertia on the wheel is more. You will have vehicle dynamic issues, right? So it means it is not good for the vehicle dynamics at a very high rates. So if you use the motor within the wheel, it's great. But if you do not use the motor within the wheel, there's a lot of advantages as well. Because the motor is sitting here, the mass of the motor is not in the wheel, right? So the vehicle will have better vehicle dynamic conditions. And the other thing is, if you try to keep a big motor within the wheel, right? How big you can keep, right? There is a limitation that because of the wheel size, the wheel is defined with a specific size, right? You just can't make the wheel of different, if you want your own sizes, because there's a standard tire size as well. So you have to confine yourself within the given area. Now, when you want to make a very large produced torque, it becomes largely challenging to keep a motor within the wheel itself. So you have to go for a motor outside the wheel. So one is weight of the wheel is going to increase. Second thing is you have a space constraints. All of these things going to impact on the vehicle dynamics. So you will go for an option called non-hub motor configuration, where the motor is outside the wheel. Any questions from anyone on these topics? All right. So if you're done with this, then we're going to go for a next chapter or next slide. So then we have a motor controller, right? So the motor controller is a component which takes care of controlling the motor. So what all the motor controller can take care? So motor controller first take care of motor speed. It can take care of motor torque. These are the two larger functions which we know. When you give a throttle, right? When you just give a throttle, the motor will respond back to you by giving you a desired outcome of RPM and a torque. Who takes care of it, right? So the motor controller takes care of it. It largely a power electronics first, because you need to convert the DC to AC, right? So that is why you need a power electronic system. So if you are a good guy in the areas of power electronics, or if you want to be a guy in the power electronics, this is one of the area, right? So it can be in other areas as well, such as chargers, or it could be also something like DC-DC converters, right? They're also power electronic components, but here also this is a very little more challenging system than a chargers, or comparative to something like a DC-DC converters, because the dynamics of switching is very, very fast, right? So with that considerations, somebody from power electronics typically plays a very vital role here. The same way, if somebody would like to work more in the algorithm side, where you write algorithms for motor controls, you can also become an algorithm engineer. Then on top of all these things, obviously somebody who can do a PCB design. It is called embedded hardware, right? So where we talk about placing the components, positioning the components, EMI, EMC requirements, And then top of it, there are various other things that take care of designing the PCB itself, right? So these are the three areas where you can explore yourself as an engineer. On the side of technology, apart from controlling motor speed, motor torque, the motor controller also takes care of various different functions. It could be a mode selection, it could be a cooling system arrangements, or it could be a functionality as well as RPM identification. It could be a functionality as well to take care of regenerative braking. A lot of these things, the motor controller also take care of it in the electric vehicle. So any questions from anyone at this moment? Let's just go to the YouTube channel to see if there is any participants have any questions. Right. So Ravindra Pratap Singh, good. So good to see your question, Ravindra Pratap. So as we see that the motor for a EV application has to be already defined you with like 7 or 8 parameters, right? It means the motor should be better and more, flexible for EV applications. Maybe it's weight to power ratio, weight to volume ratio, volume to power ratio. Like this, a lot of parameters will come into a picture, and efficiency also as a parameter. The DC motor do not provide such advantages compared to AC motors, right? So that is why we use a AC motors than compared to a DC motors in the tractive applications, because they are much inefficient, they consume larger space, they are heavier, then the control of the motor is not so advanced as compared to the AC motors. That is why we go for a AC motors compared to DC motors. Okay, any other questions from anyone? Okay, do we have a PDF study material for this session? So no, we do not have a PDF study material. The same session is recorded as of now on the YouTube, so you can still access the same session as well. Okay, anybody have any technical questions that we can discuss in the session? Okay, so Sharath, we do not have something as PDF material at this moment, but yeah, we will try if we can share, but right now it is not available. These recordings are always available. You can surely watch them through our YouTube channel. So now let's go to the next topic, that is EV subsystems, cells, module, pack, thermals, and mechanical system. So first of all, these cells are the very core elements of any vehicle, right? Because if the cells, whatever the technology of cells will define the technology, advancements of battery pack, and then it defines advancements of vehicle as well. So for you to understand the scope, so not everybody manufactures their own cells. Like Tata Motors will not build the cells on their own, correct? The Tata Motors will buy a cell from some other vendor. So there is companies like LG, Panasonic, Samsung, Calb, A123, or so many other companies are there who makes cells, right? Who make cells. So then they sell the cells to a battery pack manufacturers. Again, sometimes Mahindra or Tata Motors may not make their own battery pack, right? It means they do not have the assembly line also. So they give it to some other company. Those companies will make the battery pack at their facility. All right. They assemble the battery pack to make it as a pack. Then they supply the whole battery pack to the Tata Motors, and where they will be able to integrate the battery pack with a vehicle. So when you talk through this whole journey, so something should start from the cell. It means somebody should manufacture a cell or develop a technology for the cells. That means it involves a lot of electrochemistry. It also involves a lot of mechanical engineering as well. So you can see a lot of scope to work as an engineer in the areas of electrochemistry or on the mechanical design of a cell as well at the companies who manufacture cells. So then once the cells are available, you can build a pack or a module. So here also integrating a cell, right, to the module is a very large amount of mechanical engineering activity, because you need to properly put the cells together, or else when you have an accident, all of the cells can get damaged. Okay, it can be a serious problem. So to avoid this happen, the mechanically and electrically, the whole battery pack is supposed to be properly integrated. So there's a lot of design and development research that happens in the process of getting the modules done. And then finally, you integrate the module into multiple modules together to form a complete battery pack. So that's what you see in the whole slide here. You get a cell, you make a module, from the module you build a battery pack. All right. So then on top of all these things, you need to have a cooling system, you need to have an electrical system. So all of these systems will come into the larger picture to design a whole battery pack. So there's a lot of scope for us guys from mechanical engineering, also slightly from the electrical engineering, to design a battery pack. So then next, let's go to the next topic on the areas of other subsystem, that is cells safety. So you might have seen that Samsung, catching a fire, right? So where there is some good or bad reasons, right? So they can be very hazardous as possible, because you would have seen that a lot of scenarios, people are just carrying the phone in their pocket, and then it catches a fire, and then that can be very hazardous as possible, right? So to avoid this situation to happen, so we use a system that can ensure a safety for the batteries or a cells in picture, right? So what is the objective? The cells, typically lithium ion cells, right? They are susceptible for fire. Okay, it means they're not very safe because they have inherent possibilities of catching a fire. It could be so easily they can catch a fire, or sometimes it is protected in a way that it can reduce the instance of happening a fire. Correct? So to make that thing happen, that is why we have a battery management system. It is basically a device, an electronic device that takes care of batteries safety. Correct? So because the safety parameters such as low voltage protection, high voltage protection, high current protection, it could be low temperature protection, high temperature protection, like these things, whenever the battery is operating above a specific safety value, then the BMS will shut down the circuit, or it will disengage the battery pack to protect the battery pack. Okay, it's an example like this. Imagine you're boiling the milk on the stove. You see that it is going to come out of the vessel when it is boiling. So what do? You shut down the or you turn off the fire, right? So by doing that, you would avoid the circumstance. The same way here also, What happens to the battery pack is if it is going above a specific temperature limit, then you just have to cut down the battery so that it just stops, and then you don't go into a hazard of fire. So that is an objective of the battery management system. One of the objective. So if it observes an increase in temperature, automatically it should cut down the discharge circuit. Like in similar, it also takes care of charging. It is taking care of ensuring while the charging if there is a temperature rise and stuff like that. Okay. So with all these things, there is a system which is an electronic system which ensures a safety for the battery pack. So that is what is called as the battery management system. So now, who can find career opportunities in these areas? If you see a battery management system, first of all, there's a lot of scope for engineers from electrical engineering and electronics engineering to design this battery management systems. Okay. Second thing, there's a lot of scope for somebody who would also like to become algorithm engineers, okay, who can write algorithms for the batteries in place. Then there's a lot of activities that take care of software integration, testing, validation. A lot of these things will come into a picture. That is where you can find opportunities as an engineer. But what you should know to become a BMS engineer, you can have a prerequisite knowledge on batteries. You can have a prerequisite knowledge on working with BMSs, designing your own BMSs, or writing algorithms for those BMSs. Then you are a person with an additional skill set to become a EV engineer, all right, or a BMS engineer. So then the next topic would be on the chargers. Now let's go to the chat box and see, is there any questions that you guys have regarding the topics that we have discussed here. Floor is open for QA. If anybody have any questions, please drop the queries in the chat box. All right, so anyone have any questions? All right, so we don't see a question on the chat box right now. Then we can move to the next topic, that is on the chargers. So, it's a very, very important component because without a charger, how do you charge the batteries, right? You can't directly charge the batteries without any a component called chargers, right? So what is the functionality as a charger? It basically takes the energy from the grid, it converts that energy into a DC, and then it supplies that to the battery pack, right? This is what it largely does as a component. So, but in the meantime of it, there are a lot of things that are there in the charger. One thing, there's a lot of fluctuations in the grid power supply. It means there's a lot of harmonics. So when the supply comes to the charger, first it needs to fill unnecessary fluctuations, right? There's a lot of filtering circuit. And then you get the power supply as a proper one, and then you need to convert that into DC. Imagine you're getting about 220 volt AC, you need to convert that into a 48 volt DC. So to supply that to a battery. Second thing, you need to regulate the output that goes to the battery, because the battery has to be charged in a very specific fashion called as a CCCV, right? Constant current and a constant voltage. That is a proven technical method to charge the batteries, right? So your charger should be capable of regulating the current and a voltage that goes into the battery pack, all right? That means the battery should be getting charged properly with the right chargers. This is one thing. Then on top of all these things, there is something called slow charger, or also called as an onboard charger, or also called as an AC charger. Then there is something called as a fast charger, right? The slow chargers are typically like 3.5 kilowatt. That's a max. Because in India, right, we get to 20 volt, and an average is about 15 amps what you can draw from a big AH socket. So if it is 220 into 15, whatever you get is somewhere below 3.5 kilowatt. So you can charge your vehicle from your home socket as well, provided that you need to have a charger, correct? So now going to the further points of it, as a fast charger, it takes a lot of time to charge your vehicle with a slow charger. Because imagine if your battery pack is 36 kilowatt, okay, 36 kilowatt. If your charger is about 3.5 kilowatt, it may take somewhere about 12 to 15 hours to get charged. It means you have to keep the whole vehicle at, let's say, 9 o'clock, and then the next day, 9 o'clock, you can expect the vehicle to be fully charged. So, but we may not have that much of time always, right? That is when fast chargers are coming into the picture. Fast chargers are the ones where the charging happens more quickly, so that charger can supply a very high amount of current or voltages. So for the fast chargers, the supply itself is completely different. Okay, you can't just simply give a 220 volt supply. You will give a very higher voltage so that the charger can do a conversion at a very higher rate. So typically these fast chargers are DC chargers. It means they can directly give a power supply up to like 200 kilowatt per hour. It means you can charge a vehicle within like 10 seconds, 10 minutes to 20 minutes, provided you have a battery technology. All right. And then now let's go to the questions here. We see like a couple of questions. Vanshita, right? Are there any thermal conductive and electrically insulative material to be used in the battery box? Okay, it's a fantastic question. So absolutely, there's a lot of consideration to choose a material that's supposed to be used in the battery pack applications. How can we control the SOH of the battery? So how can we control the SOH? See, there is influencing parameters you can use to control the battery pack, our cells SOH. So you should not operate the battery very aggressively, right? You should not operate the battery above and below specific temperatures. You should charge the battery with a proper charger. You should keep the SOH as healthy as possible, SOC healthy as possible. So by this way, you can actually enhance SOH, but there is no parameter that if I set it like this, the SOH will improvise. All right. There are parameters which influence. If you control the parameters properly, the SOH will be better for a longer periods. All right. So cool. I think that's all the questions we see right now on the chat box. Right. So if somebody want to be in the areas of charging systems, right? So you should be very good in power electronics. You should be good in embedded controls, the power electronic controls. You can be good in design. You can be good in testing standards and stuff like that. Right. So there's a lot of opportunity for the chargers. So at the last, we have one slide where we talk about auxiliary components, right? Apart from all the main components, there are also auxiliary components, such as like if we take a DC-DC converter, it also requires cooling because there's a lot of heat being produced in the DC-DC converter. Then there's a lot of lighting systems. They also require energy. Then we have a battery heating system and a cooling system that looks like this on the screen right now. Then we have also other systems such as steering system that requires energy. The braking system has a vacuum system that now it is not there, it requires energy. Then we have our HVAC system, right, which is basically heating, ventilation, and air conditioning. You want to make your cabin cooler or cabin hotter, you require the electrical energy again. It means all of these components has to be designed properly so that your whole system functions as together. So this is the end of the session as a part of this whole topic on the overview of subsystems. There's a lot of opportunity for everybody to get a career in the EV sector. So at Decibels, we provide fantastic courses that can help you to get your career as well. So let's take any questions in the chat box here on the YouTube. So if you have any questions, so over to you guys. Please drop the questions. The floor is open for QA for another 10 minutes. Okay, anybody have any questions at this moment? All right, so maybe some people have this lag between the stream. You may be taking some time to ask questions as well. Okay, so what is battery life? All right, so it's a very descriptive answer that I can give. A life is something defined with respect to an application. Okay, so let's say starting with automotive. So let's say you buy a vehicle today, and let's say June 6th, right? And you want to use a vehicle for X number of years. Let's say you can use a vehicle till like June 2027. Right? You bought it in 2022 to 27. This is close about like 5 years or something like that. So when you brought a vehicle for the first day, it was giving you 100 kilometers when you charge. After 5 years, the vehicle may be only giving you like 760 kilometers. Okay. This is the parameter of range. It means once you charge your vehicle, it is called as capacity retention. Okay. It means how much the battery can hold when you start using the battery for a life over the life. Then there's something called power fading. It means the battery or a cell will tend to lose its ability to give a sudden output, right? So it is like you're discharging the water at a very high pressure. So the same way, when you accelerate a vehicle, the motor should be able to get a lot of current. If the cell has lost its ability to give a power, it's called power fading. It gradually happens over a lifetime of the cell. So when these two becomes above a certain limit, then we say, okay, cell is not suitable for an EV application. Okay, that is the end of life for EV application. Okay, then you can take out the cell or a battery pack. You can use it for a home application, as I said, home UPS. Because in UPS, no, you don't have large surge of requirements suddenly, correct? Even if it is there, it is only there for a few seconds when the main power supply cuts off, right? So that is how, again, when you start using the battery for a UPS application, after 5 years to 10 years, even this battery become non-usable for a home UPS also, because it loses still capacity and a power. It is capacity fading and a power fading. So these are the two factors that you define overall as a life of the cell. So how CCS charging happens? Okay. So CCS, there is no big difference in CCS. CCS is something where you can do a combined charge, right? You can do a AC also, you can do a DC also. See, it is just like you can combine both the system together and put it over there. The only thing is the power electronics is slightly different in the CCS, combined charging standards. It means you can supply AC if you require slow charging. You can supply DC if you require fast charging. Which software we can use for BMS? Okay, so see, this is like not a software like Python or a programming language or something like that. End of the day, what goes into the microcontroller is C, right? Embedded C. That's what you can write your algorithm. You can use MATLAB, you can use Simulink, you can use whatever the softwares are there. But end of the day, all these models has to be converted to a C code, right? C code. That will be an embedded target code. That's an answer for the question with software. Why are we not using explosion-proof casing for battery? Because, okay, see, you cannot design something non-destructive, right? So it is above our possible limits. So that is the reason why it is, if you have, you're thinking like a diffusing a bomb. The thing is, your whole vehicle weight becomes so much if you have a non-destructive casing. Can you define single line statement for fast charging and slow charging? All right. So fast charging is done through DC. Slow charging is done through AC. Fast charging, you have a outside charger, typically in all the conditions. Slow charger, you have an onboard charger in most of the cases. All right. There is a limitation of what you can do as a slow charging. It is basically because of your grid can only give you somewhere about 3.5 kilowatt. If it is a fast charging, you can go up to 200 kilowatt because your supply will be largely depending upon what you can give. In this course, will we be offered SOC, SOC algorithm development using machine learning technique? Okay, so Anant, to learn just a term called SOC, it requires a lot of time. It means that itself is a very deep expertise area. You can't just jump and learn, okay, I want to learn SOC in next 10 hours. So it's a very, very designed and defined approach. We have courses on our platform at Decibels Lab. We have a 9-month course just on algorithm development for battery management systems. All right. So if you are interested, you can definitely take a look at some of the courses that we post on our platform. If I just have to show you where do you find it, you just can go to our homepage and then you can go to the course called BMS Algorithm Development. In this course, you will be able to find yourself details about just to make algorithms on SOC and SOH, how complicated it is, so that you can learn them as well. So Ravindra Pratap, what is current technology procedures to check battery in battery bank? What should be the ideal frequency to check battery? Interesting. So what is the current technology or procedure to check battery? Battery in battery pack. See, you can call it a cell because cell, module, and battery pack, right? So, but I don't get your questions very clearly, Ravindra Pratap. So, it would be great if you can just describe your question a little better. But what to switch to ML techniques instead of Kalman filter techniques? Okay, so it's an approach, all right, Anand. So you need a lot of data. From that data, so you can define algorithms and stuff like that. You can definitely find some programs which can be helpful for you. If you want to do something on a machine learning, you need to have a data. How do you collect data? What kind of data is required? Even just to before jump into machine learning, you should know what outcome do you want to expect so that the machine learning algorithm is capable of providing that as well. So that what kind of data is required so that your machine learning algorithm can make some meaningful sense, right? So there are a lot of things that happens in between. So if you are interested, you can connect with me personally. You can write your email to my email ID. It is suraj@decibelslab. you can feel comfortable to write an email, I can look into it. I can come back to you as well. What if we use more than 16 batteries modules or 1701 for batteries in Tesla model? See, I mean, there are advantages and limitations if the technology is not done well, right? So if you come to a specific point of 7104 batteries, yeah, those are the formats, right, where you can use for applications in EV. Again, not everybody have that kind of a format technology being proven. So you can reduce number of cells. It means you can reduce the complexity of manufacturing. You can reduce the weight of the battery pack because you use less components, and then it could bring more ease of developing the whole technology in place. But if it is not done properly, it can be more dangerous as well. Right. So we do not work on active balancing as of today, Anand, as it is not in the scope. Just as a research, I can surely come back to you on this. Okay. Any other questions anybody have? Okay, so yeah, right now the balancing is a demonstration that we have done on one of the hardware. Yeah, we don't have something that we can directly give you at this moment as a handy on the course. And okay, perfect. So yeah, I will be very happy. We could do a one-to-one discussion, Anand, definitely on this topic. Maybe this session is more on the generalized way. About the master course, I think we will be very glad to connect with you. You can drop an email to my email ID. That is my first name and the company name, and we can connect definitely on this and help you out personally. Does Tesla use active balancing or passive balancing? Not very much aware as of now. We can check and come back to you, Karan Kumar. Okay, awesome. So good. So it's a good session, and we feel very happy that everybody was interactive, and you were able to ask questions. I believe I was able to meet your expectations. So it's a great interaction with all of you, and keep learning. We have a lot of programs on our platform at Decibels Lab that can help you out in creating things for you in learning. And thanks again for everybody for attending the session today. For the afternoon session, there will be a different link for you to attend the live session, but you can subscribe to our YouTube channel and you will automatically get a notification when we have a live session after this one. All right. So until then, thanks a lot, everyone. Good day to all of you, and enjoy the next session as well with the next trainer. That is Mr. Krishna. Thank you very much.
Thank you, sir, for sharing your wonderful knowledge on EV subsystems with us. And now for the second session, we have Mr. Krishna, sir, Senior Simulation Engineer, Decibels Lab. And the next session will begin on 11:45 a.m.
Thank you, Ritika, for giving the inputs. So we'll start the session soon with Krishna. Thank you very much again, all of you.